Alright, so this is 2020 internal Science Paper 1. So in this representation, I'm going to answer question B4, which is coming from work, energy, and power. Work, energy, and power. So work, energy, work and energy is measured in where? In joules. Work and energy is measured in joules, and then power is measured in watts. So figure B4.1 below is a diagram showing a stone of mass 2 kgs that was pushed up a slope from Q to R. So now, whenever you have been given the question, the first thing you need to correct the what? The data. So in this case here, we are having the mass of a stone to be what? 2 kgs. Okay, so 2 kgs. Now, on this part here, they are saying we are having T and R, which is determining the what? The height. Then as for Q, that is where now, now we are having the starting point. Okay, so the question is saying 72 joules of work was done in moving the stone up the slope from Q to R. So 72 joules of work was done in moving the stone up to the slope from Q to R. Now, work and energy is measured in where? In joules. So which means the work done here, the work done is equal to what? 72. Okay. So the first question is saying, and remember I'm saying work done is equal to what? 72. So as for question A saying, what is the potential energy of the stone at R? So now, to make you understand on this part here, of course the answer here is what? 72 joules. 70 what? 72 joules. So I'm going to say work done is equal to what? Force multiplied by distance. Now we know that force is equal to what? Mass multiplied by acceleration. So in this case here, we can take acceleration due to gravity. So where there is the force in our work done, we can put what? Mg. Okay, we can put what? Mg. So therefore we can say work done is equal to what? Mass multiplied by gravity multiplied by what? H. And we know that potential energy is equal to what? Mg multiplied by what? Height. So in this case they are going to have the same energy. So the answer is what? 72 joules. So as for joules, it is represented by what? Capital letter J. So in this case, if you forget to put the correct unit, which is what? Joules, the answer is going to be what? Wrong. Okay. So the next one, which is B, is saying if the stone falls through side RT, what would its potential energy be at S, the midpoint of its what? 4. So now when they say midpoint, which means that is what? That is the midpoint, yes. So the distance from R to S is equal to the distance from S to T. Okay, it's like half. So this one as for half the way of RT. So in this case here, the stone is having 72 joules at point what? R. Then I was saying potential energy is determined by the what? By the height. So in this case here, where the stone falls at the midpoint of S, we are going to find that the potential energy is going to be equal to what? The kinetic energy. So in this case here, we are going to say if potential energy is equal to kinetic energy at point S, the midpoint, we are going to find that for us to calculate the potential energy at S, I'm going to say 72 divided by what? By 2. So these 2 years coming from the potential energy and the kinetic energy. Since I know that at the midpoint, potential energy is equal to what? The kinetic energy. So when I divide here, I'm going to get what? 36 what? Joules. So our new potential energy is going to what? 36 joules. Okay. So now, what usually happens is like this. Once the stone falls at the ground, so in this case here, once the stone falls at T, we are going to find that potential energy is going to be what? 0 joules, and the kinetic energy will be what? 72 joules. So on this part here, potential energy is determined by the what? By the height. So as you go up, there will be increase in potential energy, and then as you go up, there will be decline in kinetic energy, but as you go down, there will be increase in kinetic energy and decrease in potential energy. Okay, then the next one, which is C, is saying calculate the height, calculate what? The height, which is TR. So in this case here, I'm going to say, for me to calculate the height, since I know that potential energy is equal to mg multiplied by what? H. So in this case here, like the way I was saying, it's very, very important when you have been given a question to correct data. So, for us to calculate the height, I'm going to say the potential energy at R is what? 72 joules. The potential energy at R is what? 72 what? Joules. So in this case here, don't use 36. They are saying the height TR, unless they were saying TAC, then you are supposed to use what? 36. Now in this case here, they are saying TR. So we are going to get the potential energy to be 72 joules is equal to the mass. The mass here, in the question they were saying the mass is what? 2 kgs multiplied by the gravity, which is 10 newtons per kgs, multiplied by what? The height, which we don't have. So in this case here, I'm going to multiply 2 kgs multiplied by 10. I'm going to get what? 10 newtons multiplied by what? H. So I'm looking for H, so I'm going to divide by what? By 20 newtons. Even here by what? By 20 newtons. Then my height is going to be 3.6 meters. 3.6 meters. Remember, height is measured in meters. Then the last one, which is Roman numeral number 2. So as for Roman numeral number 2 is saying the velocity of the stone just before it strikes the ground. So now, the I was saying on this part here, when the stone is falling from R, once it reaches the ground, they will begin in kinetic energy. So in this case here, our kinetic energy is going to be what? It is going to be 72 joules. Then the potential energy is going to be what? 0 joules. Now, since we know that kinetic energy is equal to half multiplied by mass multiplied by v squared. Now, here we are calculating what? We are calculating the velocity, which is v. Okay, so here I'm going to cross multiply. I'm going to balance this one by 1, then cross multiply. So I'm going to say 2 multiplied by kinetic energy. I'm going to get 2 kinetic energy is equal to m v squared. Now, since here I'm looking for v, which is the velocity, I'm going to divide by what? By m. So m and m, they are going to cancel each other. So I'm going to remain with what? V squared. So v squared is equal to what? 2 kinetic energy over what? Mass. Then from there now, we are looking for only velocity, not velocity squared. So here I'm going to introduce the square root to both sides. So the square root is going to cancel with the power 2 to the v squared. Then I'm going to remain with what? V. So v is equal to the square root of 2 kinetic energy, okay, over what? Mass. So in this case here, I'm going to say v is equal to the square root 2 multiplied by the kinetic energy. Remember, I was saying once the stone strikes the ground, they will begin in kinetic energy. So our kinetic energy is going to be what? 72 joules over what? 2 kgs. Now I'm going to say 2 and 2, they are going to cancel each other. 2 and 2, they are going to cancel each other. So I'm going to find the square root of 72. So the square root of 72 is going to be what? 8.48. Okay, so here I'm just going to round it off. So 8.48 and so on. But as for me, I'm just going to round this one off. So I'm going to say velocity is equal to what? 9 meters per second. So we need also to include the what? The units. Okay, so that was the last one. If you are new to this channel, kindly subscribe for more videos. Thanks for watching.